Hello everyone, welcome to the channel. Today we are going to start with chapter number 4, that is carbon and its compounds. In this particular video today I will introduce you to carbon, why carbon is very much important to us, what are covalent compounds and how carbon forms covalent compounds. So we will learn all these things. Let's start with the introduction to the carbon. There are 118 elements present in the periodic table, but here we are talking about only one element, that is carbon. Why? We shall be learning about carbon, an element which is of immense significance to us in both its elemental as well as in the combined form. It means that there are n number of compounds are present which are made up of carbon. There are more than 7 million carbon compounds are present on the Earth's surface. So you can imagine how carbon is important for us. Carbon is the basic building block of life. All the organisms are made up of carbon, and that's why we are using carbon dating technique to find out the age of the object. Going further, you know very well that our body is having many things made up of carbon, like sugar, DNA, proteins, fats, carbohydrates, etc. 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 Not everything, but most of the things. Like water is also there in our body, but water is not having any carbon in it, right? So most of the things are made up of carbon. That is the important part you have to remember. Apart from that, all the fossil fuels contains carbon, and that's why when you burn the fossil fuel they generate carbon dioxide along with the energy, right? Along with the fossil fuel, if you burn the wood also, wax also, right? So they also generate carbon dioxide because all of them are made up of carbon. Going further, we are using carbon in the medicine as well. If you have learned about carbon nanotubes, then you must have heard that this carbon nanotubes we are using in carbon diagnosis. Cancer diagnosis therapy. Yeah. So why we are using it? Because of its unique physiochemical property. So that is one of the basic use of carbon in medicine. Not only just to diagnose the carbon, but almost all the medicines are made up of carbon. Next, going further, there are few allotropes of carbon present in the nature. Allotropes means different forms of the carbon. As you see on your screen, we have diamond, graphite, graphene, Buckminster fullerene, right? All these are the forms of carbon. And we are much more interested in diamond. Why? Because it is valuable, right? And there were some stories, if you have seen videos on YouTube, then you must have seen that one of the video where they're talking about how to make a diamond from the coal by putting coal in peanut butter. Yeah, they have that experiment done on YouTube. If you check YouTube after my video, you will understand. But that is fake video. You can't prepare or you can't form diamond like that. Okay, because to form that one piece of diamond, it takes many years. Under the high pressure, specific temperature, you are forming diamond. If you start forming diamond in the lab like this with the peanut butter, then what will happen? Paisa hi paisa hoga, right? But which is not the reality. Okay, so don't trust such kind of videos. They are fake videos. So I hope you understand the importance of carbon in our day-to-day life. Okay, and going further, in general, we can say that that food, clothes, medicines, books, or many of these things are made up of carbon. The amount of carbon present in the earth crust and in the atmosphere is quite mere. Means what? Very less. It's not very high. It's very less actually. If you see in the earth crust, we have only 0.02% of the carbon in the form of mineral like carbonates, hydrocarbonates, coal, petroleum, etc. etc. And in the atmosphere, it is just 0.03% of the carbon dioxide. Means in air also, the percentage of carbon is very less, right? In spite of this small amount of carbon available in the nature, the importance of carbon seems to be immense. We can't deny the fact that carbon is very much important for us. Then Going further, we have to learn why carbon is forming these many compounds. As I said few minutes back, there are more than 7 million of carbon compounds are there. Then why I'm saying that, how carbon is forming these many compounds, right? We will get this answer, but before that you need to understand covalent bond. Okay, so reactivity of elements is explained as their tendency to attain a completely filled outer shell, that is, attain noble gas configuration. Everyone knows that. All the elements except noble gases, they try to either gain or lose or share the electron to complete their octet. And once they complete their octet, we say that they are now stable. So same way, carbon, which is having atomic number 6, right, and having electronic configuration 2, 4, needs 4 electron to complete its octet. So it can complete its octet by either donating 4 electron or accepting 4 electron or by sharing 4 electron. Then what is the best way for carbon? Like how carbon will complete its octet? Either donating or accepting or sharing. So to learn about it, we need to check what are the possibilities. What will happen if it gain 4 electron? What will happen if it lose 4 electron? And what will happen if it share 4 electron? So let's start. First condition, if carbon gain 4 electron. If carbon gain 4 electron, then what will happen? This 2, 4 will become 2, 8. But don't forget that in this 2, 4, there are 6 electrons and 6 protons were there, right? But when this carbon will gain 4 extra electron, then electron number will 10, but your protons are still 6, right? But what is the problem here? It would be difficult for the nucleus, that is 6 protons, to hold these 10 electrons. They cannot handle these 10 electrons. Means this C4 minus will become highly unstable, and that's why gaining 4 electron is not easy. It's not acceptable. Okay. Going further, let's learn what if it donate 4 electron. Okay. So if carbon donate its 4 electron, then what will happen? If it is having 2 and 4 like 6 electron, then it's okay. But if it donate its 4 electron from the outermost shell, then it will be having only 2 electron in the outermost shell. But it would be require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with a 6 proton in its nucleus holding on its 2 electron. Means what? If you want to remove 4 electrons. So if you see the structures, this is nucleus, this is the first shell, and this is second shell. Sorry for my beautiful diagram. 1, 2, 3, 4. Okay. So here you have 4 electron in the outermost shell and 2 electron in the first shell. Now to remove the first electron, it will require some amount of energy. Now if you want to remove 2 electron, then what will happen? It will require little bit more energy than the previous one, right? When you want to remove 3 electron, much more than that. 4th electron, much more than that. So if you want to remove all these 4 electron, it's not easy. It will require tremendous amount of energy, and that's why again possibility of donation of 4 electron is not good idea, and that's why it will not gain 4 electron, it will not donate 4 electrons. So what it will do? It will share the 4 electron. To understand that, carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with the atoms of other elements. For example, either carbon will share its 4 electron with other carbon, or it will share with other elements like hydrogen, sulfur, oxygen, etc, etc. So that's where we are starting with our study of covalent compounds or covalent bond. So let's begin. The simplest molecule formed in this manner is the hydrogen. If you see hydrogen having atomic number 1, with the electronic configuration 1 only. So in the outermost shell of hydrogen, you have 1 electron. And hydrogen cannot complete its octet because in the first shell maximum you can accommodate 2 electrons, not 8. And that's why hydrogen will go for completion of duplet, not octet. But again, problem is, if hydrogen donate its 1 electron, then what will happen? It will have nothing with it, only that 1 proton will left in the nucleus, and this nucleus of the hydrogen will become highly unstable, and that's why we need to take another hydrogen which is there in the same situation. So what they will do, they will have a deal with each other. The one hydrogen will say to other hydrogen, hey bro, let's do one deal. You give me 1 electron, I will give you 1 electron. It means like let's share the electron, and let's try to complete the duplet here, so that you will be get stable, I will also get stable, and in this way we will be happy. So other hydrogen say, okay, why not, let's do it, it's a good idea. And both the hydrogen will combine together like this to form duplet by sharing the electron. Here I haven't shown any arrow, right? There is no transfer of electron. The way there is a transfer of electron in the ionic compound, in this case there is no transfer of electron. You need to understand that there is a sharing of electron from each side. There will be equal electrons are get shared, and that's why you will see that that hydrogen in the nature we find in the covalent bond formation, covalent bond form. So here hydrogen hydrogen single bond will be formed. Why single bond? Because from each side hydrogen has shared 1 electron each, that's why. Okay, so is there any possibility that elements can share 2 electrons or 3 electrons? What do you think? Yeah, so answer is yes, they do this. Okay, so that's what we are going to learn now. Does the molecule have double or triple bond? In the case of oxygen, what is the atomic number of oxygen? It is 8. And for oxygen, your electronic configuration will be 2, 6, right? 2, 6. So if you see the nucleus is there, then you have first shell with 2 electrons, and the outermost shell will be there with 1, 2, 3, 4, 5, 6 electrons. Now this oxygen need how many electrons to complete the octet? Oxygen needs 2 more electrons to complete the octet. Then what this one oxygen will do? Same deal. The hydrogen were having same way, here oxygen will be having deal with another oxygen. This oxygen will be having deal with another oxygen. Just a minute, let me rub this. Give me a moment. I will try to draw a little bit better. Yeah, okay. So this is the inner shell of oxygen. This is the next shell of oxygen. So there are 1, 2, 3, 4, 5, and 6, right? So here, if you see, they are going to have 6 electrons in the outermost shell. So what they will do? They will share 2 electrons from each side. Okay, and in that way they will complete their octet. If I want to show this, then I will just change the color. This yellow color is not good. Just a moment. I'll use the blue one. Okay, so please check this. Again, I'm really sorry for my beautiful diagram. So if you see, this oxygen is having now 8 electrons in the outermost shell. In same way, other oxygen also share its 2 electrons from the other side, and in this way you will find there is oxygen oxygen double bond. Okay, in same way you will find that nitrogen is also going to share its 3 electron from the outermost shell, and it will form triple bond. Why triple bond? Because nitrogen is having atomic number 7, right, and it is having electronic configuration 2, 5. So from both sides Each nitrogen will share 3 electrons each, and in this way nitrogen nitrogen triple bond you will get here. Okay, going further, electron dot structure for methane we are going to learn. Okay, so here in this particular carbon you need to understand, or methane you need to understand, carbon is there with the electronic configuration 2, 4, and hydrogen is there with electronic configuration 1. So what will happen here? Carbon will be having its 4 electron in the outermost shell, and please remember, when bonds are getting formed, only outermost shell electron takes part in the bond formation, not the innermost shell inner shell electron. Only outermost shell electron will take part in the bond formation. So here we have this carbon, and from the outermost shell it is having how many electrons? 1, 2, 3, and it will be your 4 electrons. And what will happen next? Each of the hydrogen will be there with 1 valence electron. Okay, and they will share their electron. Like hydrogen needs just 1 electron to complete the octet, so it will be like this. This hydrogen will be like this. This hydrogen, sorry, will be like this, and in this way they will complete the octet. And what about carbon? Carbon will also share a will be having this electron from each of the hydrogen, and in this way if you calculate the number of electrons in the circle, they are nothing but the 8 electrons. So that's why we are having octet completed for our carbon. Okay, so in this way you can draw the electron dot structure for any of the covalent compound, and this is frequently asked question in the exam also. Draw the electron dot structure for methane, electron dot structure for your oxygen, electron dot structure for your nitrogen molecule, and you have to draw that. Okay, so thank you everyone, thanks for listening. Next class we will start about the versatile nature of carbon, why carbon is forming these many compounds. We will learn about it. So I request everyone to please revise this topic at home once, so that you will get some more idea about the topic. Thank you everyone, bye.